We were asked to find the rational roots and extrema for the equation p of x equal ax cubed plus bx squared plus cx. The rational roots is when p of x equals 0. So we took out the x, made this equation, put in the quadratic format, and found that b squared minus 4ac must be a perfect square and positive. Then for p prime of x, which would give us our rational extrema, we got the derivative of 3x squared plus 2bx plus c. Plugged that into the quadratic and found that 4b squared minus 12ac must also be a perfect square and positive. For p of x to have rational roots and rational extrema. For number 4, we needed to find if n squared minus 1 is divisible by 8. Now, I made an equation that is always odd for any n, 2n plus 1, plugged it back in, and got 4n squared plus 4n. Now I'll set that equal to a, did a few examples, and found that all of it is divisible by 8. Then for another example, proof by example, I found that for every odd n, if you were to plug it into the irregular equation, is also divisible by 8. For number 5, we were asked to find out how many switches in a hallway of 1,000 light switches would be on if every nth person switches every nth switch on or off, depending if it was off or on. Now I made a matrix right here and added them all up from 1 to 10 light switches on the top and the people going through the hallway on the left, and added them all up and got a total. For every odd number in here, that means that light switch is on. For every even, that means that light switch is off. And then I made up an equation by example from this, and this shows me that all perfect squares are on. So I made an equation. The amount of switches that are on, W, equal the summation from n equal 1 to n 10 of the light switches. Every nth light switch equals the square root of some number, 10. Since I did 1 to 10, I got 3.16, but that couldn't be possible because 0.16 light switches can't be on. But we know that 3 are on, so that must be the number. So then I did a little bit more proof by example and found that all prime switches are also off. Did from n equal 1 to 100, which is 10, which means that 100, 81, 64, 49, 31, 25, 16, 9, 4, and 1 are all on light switches. So then I did the 1,000, from 1 to 1,000. Got the square root of 1,000 equal to 31.62. But 0.62 light switches can't be on, so 31 squared is the last light switch on, which corresponds to 961. These are all the light switches that are on, adding up to 31, which seems right. And that means all of those are on, and the square root of 1,000 equal 31 is the correct amount of light switches that are on, where 31 is the amount of light switches that are on. Thank you.